Okay, so I've made an empty project called hash chain, and inside there to start with, I've dumped in a worker object that we can use as cannon fodder for dumping into this hash table. Okay? So let's start out by making the hash table class. And let's see if we can figure out what sort of stuff it's going to hold. So from the diagram, what's the first thing that you would build in the constructor? So we'll do our constructor here with public hash table. First thing? An array. So we're going to have an array of what kind of things? Nodes at this point, because the nodes are going to chain things together. Oops, I guess we need a node class. So let's quickly write private class node. Only needs to be seen inside this thing. So here's a node class. A node class keeps an E, the thing that it's trying to store. So I guess that means that we need to store specifically E-type things in our hash table. And it also contains a node next. And we'll write the constructor. And just remember the thing that's being passed in. And next is going to end up as empty. So there's our node thing. So at this point, back to hash table, we know that it now needs to contain an array of nodes. So that's going to be private node array, and we'll call it table for want of something better, because it's really just a table or array or something like that. Okay, so an array of nodes, so that means there's going to be a chain off of every single position in the array. Okay, so that means we have to initialize the table variable. So that's a new, want to give this a try, node array of some size. For now, we'll just put in the size. Doesn't really matter. We'll figure out how to make it grow later or select the size.
Just to clarify, is the entire table one array, or is it each spot in the table its own array?
There's one array with chains running off of it. Okay. And unfortunately, nah, can't do that. This is yet another weirdity with Java generics. You'd sort of like to do that, but you can't. And so we said that our workaround for it was to say new object array and then cast it to node array afterwards to say, well, thank you very much, but this is what I'm going to use it for. And we'll leave that there for a while, even though I'll tell you right now it's going to break eventually. Okay, so there's our array of things. Most of those warnings are just because it's not, haven't done anything with those variables yet.
How do you gain the difference?
Can't talk about you specifically. Can't see your code, so don't know. Okay. So let's do public void add. Actually, in a hash table, it would be called put. What are you putting into the table?
Nodes? Whatever you want?
Yeah, realistically cats.
Realistically cats, yeah, because the perfect things to squash into a table. What did we say was the purpose of hash tables? pair that thing with that thing. Okay? And we were always keeping track of both things because they belong together. Okay? So in some senses, the other way you can think of hash tables is they pair arbitrary things together. So a dictionary, right, pairs a word with its definition, right? So a word with information about it, right? So you're trying to group two things together that haven't necessarily belonged together before temporarily is typically how they're used. Okay? So in this case, we're actually, when we put things into the table, we're putting in two things. We're saying, here's the thing that's gonna be the unique thing, and here's the thing that I want you to store based on that being unique. Okay? Unique in computer science means the word key, and that thing's the value that's being stored. So the other way that you see these things when they talk about hash tables, they always talk about them as having key value pairs on purpose, because you're pairing the two things together. Okay? So in actual fact, what you get when you put things in is you get a key and a value like that. And so here we are graduating in generics. This is the first time, rather than saying the hash table contains one thing, the hash table actually contains two of these notations together. It contains a key and a value that way. And so the thing that you're trying to store into the table, for now, we'll say is a value, even though that's a bit of a lie. Okay? Why are those things generic? They're generic because, notice in this case, this is a pairing of student versus student. Student supplies the key, the magic number that places them in the table. So this is student, student. So key is student, value is student. In this case, this is string gives you the magic number that puts that student into the table. So this is a pairing of string as the key, as the unique thing, versus student as the thing. Okay? So when you make a new hash table, we're going to have to supply what we're putting in to generate the key versus what we're putting in to generate the value. And so maybe now's the time to go, and we'll have a quick look at a driver program just to emphasize that concept. So let's make a new driver just temporarily. So let's do the two different examples. One thing you could do is you can say, I'm going to make a hash table that's got, do the easy one first, string paired with worker. And I might as well do the new part too. I think it might even allow me to do that if I'm lucky. No, maybe not. Yeah, it does. Okay, so there's where the Java, that angle bracket notation comes in a little more handy in Java 7, is that you don't have to repeat that same thing on the right-hand side. Okay, so that would be one way of doing it. And so then what you would do is, let's just make a new worker here. New worker with Fred and whatever it was, president, I think. And so if we wanted to remind ourselves who Fred was, you know, and we made our table of things, then maybe we'd have string table dot put, and we'd have to supply a string here. So we'd say first in union, and the value we'd supply would be Fred. So maybe he was the founder. There's a better word for it. Okay? So there's the sense of when I put people into this table, I'm going to make up funny names for them myself in order to describe them. Okay? And in this case, when we put stuff into the table, we ask the string to turn itself into a unique number that's just an integer in order that I can keep track of Fred in the table. Okay? The second way of using the table would be to say something like hash table of string with worker. We'll do a worker table. Well, it doesn't really get the sense of it. And notice that this is a different table. It's not the same table because we can't mix and match the kinds of things we put in. But in this case, what we would do is we would do string table dot put, and we would put Fred with Fred.
You mean for that to be worker table?
Sorry, worker table. Yeah, thanks. Notice it actually won't let me do that.
Worker table be worker and worker?
What did I do wrong here?
You have string in the hash table declaration.
Oh, sorry, yeah. Got it. Worker, worker. Thank you. Okay? And so in that case, I'm saying I'm going to get Fred to supply the information about the unique number. He's going to give me his social insurance number or whatever he gives me. He could give me his name, Fred Flintstone, convert it into a number, don't care, and I'm going to use that to store Fred's information in the table. Okay? So that's why when we get back to trying to write this thing, we actually have to care about those two pieces of information about both a key and a value. And notice by definition, the word here is that the key is supposed to be unique. And so that means that in this case, Fred has to have, for instance, a social insurance number that's unique. You shouldn't have two people with the same social insurance number, and you can't put two people with strings in the table who have the same string. There can't be two founders for this thing in order for it to work. That just wouldn't make sense. Although we'll find out later what happens when you try to replace somebody. Okay, and so for now, this is a value type thing, although that's going to change. Okay, so now we want to put these people into the table. What are you going to have to do to put them into the table? Look at the diagram here. Somebody supplied, for instance, a string and a value. And so they're going to give two pieces of information, and you've got to group those two pieces of information before you even get it onto the chain. So we need something that groups two pieces of information together, which is what? A what? No, the node is used for a different purpose. We haven't got to linking things in. We just want to group these two things together.
Isn't that a class?
That would be a class. So let's write a class that groups two things together. What do you want to call it? Well, we'll just call it a pair, for want of a better word. And a pair class just holds on to a key and a value and groups them together. So we'll need a constructor for that. Okay, so there's a class that just groups a key and a value together, takes two separate things and says, oh, for a while at least these belong together. Whole idea of a hash table. So now if you're going to put things into the table, the first thing that you do is you say, I need a pair of things, and that pair is a new pair object containing both the key and the value. And now I've grouped two objects into one. Okay? So, group two objects into one. Got Best and Fred associated with each other. Now what do you do to put them into the table?
Assign them to a node.
They're gonna have to be inside a node, because you're gonna have to chain that node into a table somehow. Okay? So the next thing that we're gonna have to do is make a node object. And sorry for the names here, but they are sort of generic. So we're gonna take the node object and we're gonna stuff the pair into it so that the node can remember the pair of things, and then we'll hook the nodes together. If I did that right. New node for, oh, okay. So now this thing, the thing that you store, that a node stores together, is no longer a v for a value, but it's a pair of things. And so that's the pair coming in, and we'll store a pair of things together there for the node. So that's the grouping mechanism again. Okay? So held the two things together with that line, and now that we're together, we can make a node and figure out how to chain them into the table. Do the easy case first. If life was good, where would they go in the table? How would you find out where they went in the table, first of all? You have to ask the key. You have to say something like, hey, key, get magic number. Right? And then you would take that, value that you get back, and do something with it. Okay? So that means anybody who's going to play this game has got to be able to give you a number, just some arbitrary number. So if we go look at worker, worker has to have get magic number, so I'm going to put that in here. Okay. Now in this case, we didn't store social insurance numbers for workers to start with, so we're in a little bit of a weird place here. You could return the magic number that was created by name. So get string to return a magic number, which it doesn't have, but that's okay. Okay, just to give the sense of you could do that. Okay. In actual fact, Java doesn't do this. This concept is already there. What did I say the other day it was called? Or just recently on the board? Hash code is the special thing that's already there. So by default, it's sort of built into Java as hash code. So you'll see it as people have to return their hash code. And in this case, what I'm going to do is, it turns out that since there's the name in there, I'm just going to return name.hashcode, because strings will, you can say, hey, give me a magic number from the string, and it will produce one. Nothing fancy about how it produces one. It just adds up the letter positions and multiplies them together. It does something like that. Okay? So that just says, hey, string, give me a unique number that represents the string, however you do it.
But the object itself doesn't have a hash code. It doesn't. There's no way for the object to automatically generate its hash code.
There's no such thing as automatic ever.
Okay.
Everybody has to find a way of making one. So like I say, if worker had social insurance number, they would probably just send back their social insurance number, because it's already a unique integer that identifies them.
But I guess what I mean is, in every object we make, every class we make, do we have to put a hash code?
You
return?
only need to have a hash code method if you're ever planning on using it in the hash table.
Okay.
And so if you never use it in a hash table, you don't need to write that method ever. So this thing is, we'll ask the thing for their magic number, which is their hash code, however we get that number. Now where do you place them in the table? What position do they belong in?
Magic position.
Well, you'd like to say that they belong in table sub magic is now going to remember the node, assuming that there's nobody else in that position, right? We'll go with the easiest thing. But our table is only 100 large, and the magic number might be significantly larger.
But we use modulus.
So this is where we use the mod function. So whatever number they give you, you turn around and you say, well, I'm going to generate the position that I actually need for the table by taking magic mod, whatever it is, table.length. Okay? And so now when we put them into the table, we'll put them in at the smaller number because we know it fits within the bounds of the table. Okay, so the summary here is, oh, okay, those two things that came in as separate entities, we need to group them together. So we'll provide a grouping mechanism so that they're now one object with the information together. Oh, we need to dump them into a table, a chain someplace, so we need to form a node so that we can hook them into the appropriate place in the chain. Oh, where do we put them in the table? Well, they're going to give us a number, whatever it is. It's probably too large, so just to be sure, we're going to scale that number back so that it fits within the size of the table, and then we'll take them and we'll dump that node into that position in the table, and assuming that there's nobody else on that chain already, that's a perfectly reasonable thing to do. So there's the easy case for at least getting them into the table. Okay, so if you understand the different steps, it's really not a lot of work. It's just step through it. And we'll stop there, and next week we'll figure out why this is broken, and then we'll figure out how to go get them back again at some point. So it's going to get a little bit more complicated, but there's the basic idea for what put does.